Good evening, all. I hope my voice is audible to everyone. Roshit sir, is I'm audible?
Hello.
Yeah,
Are
yes,
you
sir.
able to
You
hear
can
me?
start the session. Yeah, yes, sir. You're audible.
Okay, okay. Give me a moment. I will connect my whiteboard. Hi, students. Good evening. Are you able to hear me? Okay, okay. So today I'll be on video off only because I had a power cut at my area and I connected to mobile data. Okay. And let me know like if you're not able to hear me at any point of time. Okay. Okay. At any point of time, if you're not able to hear me, let me know. Okay. Okay. So good evening, Jinath. Good evening, Rani. Good evening, Mambia. Good evening, Sandhya. Okay. So what we have discussed in the last class? What we have discussed in the last class? Good evening, Anurag. Welcome. So we went with the sorting algorithms, right? Yes, we went with the sorting algorithms where we discussed where we started with bubble sort, right? Where we started with bubble sort and then we went with discussion of your insertion sort, right? And then we went with the discussion of your selection sort, where this code I did not discuss. I have given it as assignment to you, right? Homework to you, right? Have you completed this? Have you completed this? Okay. Okay, Anurag. Why is it not completed? You did not get the algorithm or the code study from ChatGPT? Like you got the algorithm? Like you got the algorithm of this selection sort. Okay, so let me explain once again the bubble sort, all these algorithms. Let us discuss once again. So how we are doing in the bubble sort? How we are doing in the bubble sort? Basically, we are comparing adjacent elements, right? We are comparing the adjacent elements. In the case of your bubble sort, we were comparing the adjacent elements. Okay, for every iteration, we'll compare the adjacent elements. So for every iteration, what will happen if we are comparing the adjacent elements, either in ascending order or descending order? Ascending order, ascending order, no issue. Good evening, Sangam. No issues. That is like we have started just now. Okay. In the case of your ascending order, we'll be checking whether the second element, whether the first element is greater than the second element, then we'll swap, right? In the case of your ascending order. Whereas in the case of your descending order, in the case of your descending order, when the first element is lesser than second element, we will swap it up, right? So we will compare the adjacent elements and then for every iteration, what we will do, what will happen? So if you are comparing the adjacent elements and we are starting going on swapping for every iteration, like in each iteration, what will happen? The largest element in the case of your ascending order, the largest element will be at the last, will be sitting at the last. Okay, the largest at the last position. Last position. That is the correct position of that last element. Okay. So this is your bubble sort. This is your bubble sort. And we have also seen how to optimize this bubble sort as well. How to optimize, we need not to go until n minus 1 iterations. For every input, we need not to go until n minus 1 iterations. So we have optimized accordingly, right? We have run the iterations, in the inner iterations, we have changed it to the inner iterations, we have changed it to n minus I minus 1. Whereas we have also taken like swap, right? Swap condition. So basically n minus I, when you're starting from 0, then n minus I minus 1. Okay. Then we have also taken a flag of swap. Like if the swap is not happening, we are stopping then and there itself. We are breaking the loop, outer loop itself. That also we have seen. Yes, that also we have seen, right? Yes. So this is how we sorted. Like, let me go to my Eclipse. Yes. So the outer loop will be running from 1 to n minus 1. Whereas the inner loop, like basically we are taking it as first iteration to n minus 1 iterations. And then the inner loop will be running from 0th element to n minus I minus 1. Okay, n minus I minus 1 it will run. And then we have taken a Boolean variable, that is flag, to check whether the elements are being swapped or not within this. Within this loop, whether the elements are swapped or not, we are checking it up. Okay, using your flag variable. Okay, if the elements are not being swapped, then what we are doing, we are breaking the loop, right? We are breaking the loop, breaking the outer loop itself. Wherever you will write the break, that loop will be break, means it will come outside, means swapping, like the sorting functionality will stop. Okay, the comparison functionality will stop. Okay, so this is how we are doing inside your bubble sort. Then in the case of your insertion sort, what we are doing, in the case of your insertion sort, what we are doing, in the case of your insertion sort, what we are doing. So if the elements are given like 23, 10, 9, then some 100, then some 150, then some 11. Suppose the elements are given like this. Then what we are doing, we are dividing the array into two parts, right? This is your unsorted part. This is your sorted part, right? This is your sorted part. We are considering this first element as already sorted and the remaining elements as unsorted. Okay. And the remaining elements as unsorted. You're able to hear me clearly, right, guys? Anywhere is missing like something? Clear. Okay. Okay. If anywhere the signal is going off and you're able to not able to hear me, then let me know. Okay, immediately in the chat box. Okay. So this is your sorted and this is your unsorted. Okay. So here what we are doing, we are taking from the unsorted array each and every element we are taking. We are comparing with the previous elements in the sorted array. We are comparing with the previous elements in the sorted array. Okay, so basically in the sorted array, what elements are there? We are comparing with that. So what will happen now? Immediately, this 10 will be taking inside a temp variable. Okay, then this 10 is compared with 23. 10 is less than 23 or greater than 23. Less than 23, right? It is less than. So if it is less than, what we need to do? We need to move the sorted element, what is there in the last. at lowest position, right? So that element will be moving to one step to the front, one step to the front. So what will happen now? Here 23 will be coming, and then 9, then 100, then 150, and then 11. Okay. Then since there are no elements before it to compare, we are directly placing the 10 here. Okay, we are directly placing the 10 here. Okay. So then what we are doing? Then we are considering now this as sorted. Okay, this as unsorted. Okay, this as unsorted. Again, what we are doing? We are taking one of the element from here. We are putting inside the temp. Okay, and then I'm comparing this temp value with the previous elements in the sorted array. So 9 is compared with 21. 9 is less than 21 or greater than 21? Less than 23, right? So what will happen now? This 23 will be moving to the one step to the front, and then 100 will be coming, then 15, then 10, and then 11. Okay. So now immediately should I place it up here? This 9. Immediately should I place it up here? This 9. What I should be doing? I will compare with the previous value. Okay. I will compare with the previous value as well. So what I will do? This is not swapping. This is not swapping. I will compare with the previous elements again. So 9 is compared with 10. So what will happen now? 9 is less than 10, right? So when it is less than 10, it will go into the front position. So 10 will be coming here, 23 will be coming here, then 100, then 15, then 10, then 11. So since there are no elements, I'll be placing the 9 here. Okay. So how many iterations are done until now? How many iterations are done? This is your I is equal to 1 iteration. This is your I is equal to second iteration, right? Then in the third iteration, so until this point, we'll be taking it as sorted and this as unsorted. Then again same. Then again same. 100 is taken into temp. 100 is taken into temp. Then this temp is compared with the previous element. Okay. Okay, that's fine. Okay, let me make it 150 only. It will be easier for us only, right? 150 and 11. Okay, so 100 is compared with 23. Less than or greater than? Less than or greater than? Greater than. So what will happen if it is greater than? I will put this at the same position. Okay, there will be no shifting happening. It will be at the same position. So 9, 10, 23, 100, and then 15, and then 150, right? This is 150 you're telling. 150 and 11. Okay. So until this point, it is sorted, it is unsorted. Okay, now again I'm taking this tempo value that is 150 here, and then I'm comparing with the previous elements again. So 150 is less than 100, greater than 100. Last iteration. 150 is less than 100, greater than 100. Greater than 100. So what will happen? This will be the perfect position for it. And then I is equal to 5. At I is equal to 5, this will be sorted and this will be unsorted. Again, we'll be comparing with the previous elements, previous element. And at this point, it will sit. Okay. So 150 will be coming there. So 9, 10, 11, 2300 and 150. Okay. So we have written the algorithm for this. We'll be using how many loops? We'll be using how many loops? We'll be using two loops, right? First one is for I is equal to 1 to number of iterations, right? So basically we'll start the loop from 1 to number of iterations, right? So basically I is equal to I less than n. So we need to run the loop until this point, right? Until this point. Okay. So basically I less than n means nothing but n minus 1. Until n minus 1, I should be running the iterations, right? Then I plus plus. Then what I need to do? I need to keep the tempo value. The tempo value will be array of I. Array of I. Okay. Then what I'll be doing? Temp is equal to array of I, and then I'll be determining the j value, that is I minus 1. And then what I'll be doing, while j greater than or equal to 0. Okay, while j greater than or equal to 0, and I need to check if array of j greater than, basically if array of j greater than temp, right? If it is greater than temp, then what I need to do, I should shift array of j plus 1. So basically at array of j plus 1, I will be keeping the array of j. Okay, array of j, and then j minus minus. Okay, within the while loop, I'll be writing this. Okay, array of j plus 1 is equal to array of j minus minus. Then what I will be doing, I'll be placing the, if if all the comparisons are done, then what I should do at j plus 1 position, since j minus minus, it will happen j minus minus, right? So because of that, I'll be, suppose there are no elements here, then j will go to minus, right? So I need to make minus 1, it will become, then I need to make it 0, right? So it will be j plus 1, not j, because you are see, j minus minus you're doing. Suppose, see, here you have come at this position, you need to keep. Now j will be minus 1, and when j is minus 1, it will come out of the loop. Okay. So now where you will be putting your tempo value at j plus 1 position. At j plus 1 position. So this is your algorithm. Okay. So this is your insertion sort. Are we clear? So once again, I have explained. Okay. And then we went with the selection sort, right? So selection sort also, quickly I will take one example. 100, 7, 9, 120, 12, and then 200. Okay. So what is selection sort? Selection sort, how it works? Selection sort, how it works? Yes. So do we need to, where the, like, do we need to form any division here? Do we need to form any division here? No or yes? No, right? So what we'll be doing? So basically the before ones will be taking now as before no elements. I'll be taking that as sorted, and whole array, whole input array will be taking it as unsorted. Okay, unsorted. And then what I'll be doing? I'll be taking the, I'll be finding out the minimum element here. Okay, basically, yes, transposing. So basically I'll find out the minimum element. What is the minimum element? The minimum element is here 7. Yes. So 7 will be coming at the first position of the array. Okay. Then that the element that is at the first position will be swapped. Okay. Will be swapped. So 100 will be coming here. 7 will be coming here. And then 9, 12, 200. Okay. Then until this point. Okay. Okay. No. So until this point, it is now sorted. Then this is unsorted. Okay. Then what I will be doing, I will find out the minimum element again. The minimum element is 9. So 9 will be swapped with the first element in the array, right? So first element is here. So I'll be swapping here, I'll be swapping here. So 9 will be coming here, 100 will be coming here, and then 12, 12, 200. Then here, what I need to do, the third iteration until this point, it is sorted now. This is unsorted. Again 12. 12 is the minimum element here. So what will happen in I is equal to fourth iteration? 7, 9, 12, 100, and then 200. Right? Then in the fourth iteration will be there or will not be there? Because in the fourth iteration there is only one element left in the unsorted array, so it is always sorted. So until where you should run the loop now? Can you tell me until where you should run the loop now? So if n minus 1, right? So for from where I should start the loop, basically I'll be starting the loop from 0 onwards, right? So I should find out, because I need to input over all the elements, right? So I'll be putting the updated element at the first position, right? So for that reason, I'll be starting the loop from 0 onwards, right? I is equal to 0, I less than, I less than n minus 1, right? So until where the loop will run now? 0, 1, 2, 3. Okay, until where? 5 minus 1. 1, 2, 3, 4, 5. 5 minus 1, which is nothing but 4, then 3. Okay, then I plus plus. Okay, and then what I should be doing? What I should be doing? I will consider starting this as a minimum element. The zeroth element as the minimum element I will consider. Okay, so move to that. So what I will do, int min is equal to I. Okay, int min is equal to I. I will drag this here. Okay. For I is equal to 0, I less than n minus 1, I plus plus. Okay. Okay. Then I'll be taking the min value. Okay. The min value will be initially I itself. Okay. I will consider the min value as I itself. Okay. And then I will start the loop for comparison of the minimum value. Okay. I will start the loop for comparison, which is lesser than 100. I wanted to compare which is lesser than 100. So for that reason, I will start the J loop from I plus 1. Okay. I plus 1. And J should run until N. Until N means till the last position it should run. Right. And then J plus plus. Okay. And then what I'll be doing, if array of J less than, so I should check the minimum value, right? So if I should check whether this array of like basically the array of J is less than min or not. Okay, is less than min or not. So for that reason, array of J less than array of min. If it is true, what I need to do? If it's true, what I need to do? If it is true, what I will do? I will change the min value. I will change the min value to J itself. I will change the main value to j itself. From I to I will change it to j. Okay, so I will find out the minimum value here. I found out the minimum value here within this for loop. Within this for loop, I was able to find out the minimum value. Then what I'll be doing? Then I will swap it up. But before swapping, I should check whether this is only a minimum value. Suppose 100 is not there. 100 is not there if you're thinking. Okay. From 7 onwards, the loop has started. Your input is from 7 only. 7, 9, 12, and 1200. Okay. So now 7, in this 7, I will take minimum as 7 itself. Then I will compare with each and every element within the inner loop. Then I will not be able to find out any minimum here. Okay, I will not be able to find out any minimum here. Then minimum will be always I itself. The minimum will be always I itself. So in that case, swapping is required. Swapping is required. No or else. Suppose your input array is 7 and 12 and 1200. No, in that case, swapping is not required, right? So if it is I only, the minimum is I only, not J, then swapping is not required. So because of the for that reason only, to minimize your swaps, what I'll be doing, I will check the condition. Okay, I will check the condition if minimum not equal to I. Minimum not equal to I, like basically the minimum is not equal to your I itself. Okay, then what I'll be doing, I will, if minimum is not equal to I only, then I will do the swap. I will do a swap. So swap, you already know, temp is equal to, what you will be doing, temp is equal to, I need to swap basically, what I need to swap, I need to swap array of I with minimum value, right? Array of I with minimum value. So array of I, temp is equal to array of I, array of I is equal to, array of I is equal to array of min. Okay, array of min is equal to temp. Okay, array of temp, min is equal to temp. Like this, I will swap it up and then I will close it. Okay, so this is how we will be writing the algorithm for this. Okay, so can you do this code quickly? Can you do this code quickly? I'll be waiting for 5 minutes. Can you do this code quickly by taking an input and try this out? Let me know if you're facing any issues. Okay. Sandhya is done. Super. Anurag, are you done? While dry run, like while I'm explaining only, I've written this code, right? This is only the code. You're asking me to dry run again. Okay. Let me go to my Eclipse and logic I have explained, right? Yeah, the same code I will write it in logic only again. The same code I will write it in the editor. That's it. So okay, let me write it down. New class, fifth class. Okay, I will explain while I write my code. I will explain. Okay. So int array is equal to what outputs we have taken. What inputs we have taken? 100, 7, 9, 12, 200, right? 100, 7, 9, 12, 200. Okay. Now I will be running the loop from int I is equal to 0 onwards. Right? I will start the loop from 0 and then I will run the loop until n minus 1. Okay, I will run the loop until n minus 1 because I need to go until where? Until this point I need to go. Okay, because anyways this will be sorted. Anyways this will be sorted itself. So what I'll be doing, I should go until this point only. So for that reason, less than n minus 1, which is array dot length minus 1. Are we clear until this point, Anurag? Yes. And then I'll be taking the inner loop for your finding of the minimum element. But before that, I will consider this as the minimum element to find out. Okay. Initially, I will consider the minimum as I itself. Okay, the minimum as I itself. Okay, because I need to swap here itself, right? So basically I will be taking the first element from the unsorted array and I will compare with each and every element. I will compare with the each and every element. I will consider this as the minimum first. So basically I will consider this as a minimum first and then I will compare this 100 with each and every element. If it is not minimum, then automatically it will change. Like that I will write the code. Okay, int min is equal to I. Okay, int min is equal to I, and then what I'll be doing, I will run a loop. I will write another loop. Int j is equal to, I need to start from I plus 1. Okay, I need to start from I plus 1. I less than, what I need to do, I should be running until what? Until this point it should run. The whole array it should run, right? To start from I and it should run until this point. So it will be I less than array dot length, array dot length. Okay. Okay. J less than array dot length. Okay, and then j plus plus. Okay, and then I'll be comparing the minimum element. Okay, so array of j less than array of min. If it is less than, then what I need to do, I will be putting that, I'll be exchanging that min to j. So what I'll be doing here, first I will take this as minimum. Okay, this as minimum. Okay, then I will compare this minimum with 7. Okay, so now what will happen? Area j is called I plus 1. J will start from here. So I will compare this 100 with 7. 100 is greater than 7, not less than 7, right? Look, so basically I will compare this 7 with 100. Okay, 7 is less than 100. It will come inside. The minimum will now become 7. The minimum will now become J. Okay, and now like that I will compare. So I will compare with area of I less than area of minimum. The minimum will become J, and then again I will run the loop. I will not stop the loop here. I'm not breaking it once I found the, because I don't know, right? There can be 6 here. There can be 6 in the rest of the array. There can be 1 in the rest of the array. There can be 5 in the rest of the array less than this. So for that reason, I need to check each and every element until n, until your 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. Until that point means I will be starting the loop from here, and until this point I should go. Okay, since 1, 2, 3, 4, 5, it will be nothing but 4. Okay, so minimum is equal to J. Are we clear until this point? Yes, and then what I'll be doing, so each and every element I will compare, and then what I'll be doing, if I should be checking, I will come out of the loop, and then I will be checking if this is not equal to I, because see here, if suppose if this is element is not there, then the minimum will be 7 itself, and the 7 is at the ith position only, the same position. The minimum will not change, right? Since we are starting the loop from here, I will be comparing this, right? I'll be comparing this with this with this, and this with this. But 7 will not change. It will not come inside, because that is the minimum. Because in this the condition will be always false for all the comparisons. So minimum will be I itself. It will not change. So if it is I, then I need to swap it here. This one I need to swap. No, right? It is not required to swap with anyone. So for that reason, what I am doing, I'm checking if minimum not equal to I only, then only you go ahead with the swap. Okay, if minimum not equal to I only, then only you go ahead and swap. So you'll be swapping. You'll be swapping which you'll be swapping your array of I with array of temp. Okay, so array of min. Okay, array of so basically I will take array of min here. Okay, so array of I is equal to array of min. Okay, array of min is equal to temp. What I'm doing. Array of I is equal to, I'll be placing the array of min. Okay, I'm doing select only, right? In array of min place, I'll be placing the temp value. Is there any mistake here? Is there any mistake? Is this mapping correct? Yes or no? Yes. So what do you need to do? Like, see, the same thing I'm putting again. Here you see, the same thing I'm putting in 18th line and 21st line. There is no swapping happening there. Means everything will be array of min only. Okay, array of I. Okay. I'll be putting the first element. I'll be putting the first element in the temp, and then I will swap your array of min at the array of I position. So basically, we can if this is 100 is there, so this will be your array of I, whereas this will be your array of min. So first I'll be putting this array of I in the temporary variable because this will be going right. If I push it this here, this value will be going up. So for that reason, I'll be placing the temporary value there, and then I will push this here, and then I will put the tempo value at this place. Okay. So let me run this. Before that, how should I run that? I will be taking a for loop and the array is how okay. Any issue here? Okay. D plus dollar. Okay. So the array is sorted now. Are we clear? Yes, Anurag, clear? Whoever has not done this code, can you try doing it on your laptop? Then I will jump into recursion. And then once I discuss the recursion concept, then I will move into the kickstart and merge sort. Ishwari, I was not speaking actually. Okay. So let me move to my whiteboard. Yeah. So before kickstart and mudstart, I wanted to discuss. I wanted to discuss recursion concept. Okay. So can anyone tell me what is recursion? What is recursion? Can anyone tell me what is recursion? Object calling copy of itself. No mod. Niharika calling by itself. Okay, what is calling by itself? What it will call? Function that calls itself. Correct. So suppose there is a method if you are writing ABC method. Okay, you are writing set of statements here and you are calling the same function again. You are calling the same function again. Can I call this as your recursive call? Yes, recursive call. I'm looping the same method call again. Okay, I'm looping over the same method call again. So if a function is calling by itself within the method, okay, within the method, not outside the method, okay. So within the
It's
method,
8
within that
o'clock.
particular method, within that particular method, if you are calling that function again, that is called as your recursion. Okay, that is called as your recursion. So suppose if I'm writing some function of n, okay, function of n I'm writing some abc of n, okay. Now again I'm calling sys out of welcome, sys out of welcome I'm calling, I'm telling, and then after this what I'm doing, I'm calling that function again, I'm calling that function again. So what will happen in this case? What will happen in this case? What will happen in this case? It will run into a infinite call, right? Infinite recursive calls, right? So basically what will happen? So basically what will happen? Every function call, every recursive call or every function call will be stored inside a stack memory. Okay, every method call or every function call. Basically in Java, we will call a function as method. Okay, we'll call a function as method. In C, we'll call that as function itself, but in Java, we'll call that as methods. Okay, so if you consider this as your stack, okay, so first call when it is calling, suppose the end value it is calling as function of some 5. Okay, from the main method, first what will happen? Main method will be called, right, by your JVM. From main method, you are calling that function. Okay, ABC of ABC of some 5. Okay, now what will happen if you consider this as your ABC itself? Okay, so ABC of 5 will be called. Okay, and then what you are doing, you are printing welcome, means one welcome will be printed here. Okay, and then what you are doing, again you are calling the function. So ABC of 4, then again you are calling that function ABC of 3, ABC of 2, ABC of 1. So like that, it will continuously call. It will continuously call for every method call, for every method call, it will be stored in the stack. Okay, it will be stored in the stack. So only when you get an error, when you get an error or compile time error, what you will get some stack trace tree at which line the error has occurred, at which function call that error has occurred, at one outline of ABC function, at some 70th line of main function. Like that you will get it in the compile time error, right, in your console. at 69 line of some other function. Like that, you will get multiple function calls, right? How it will be able to predict it? Basically, in the algorithm they will use is stack only. In the backend they will use a stack and they will follow the LIFO approach. Okay, they will follow the LIFO approach because in the backend the stack implementation only they will follow. Okay, so main then ABC of 5, ABC of 4, ABC of 3, ABC of 2, ABC of 1, ABC of 0, ABC of minus 1. Like that, it will continuously move, right? ABC of minus 1. There is no stoppage for this. And at some point of time, you will get an exception here. What is this exception? Famous exception. Famous exception it is. We have a site also on that developer site. Developers friendly site. Yes. So not stack out of bounds. I will call that a stack overflow. Stack overflow exception, right? So do you use stack overflow regularly? Yes or no? Stack overflow regularly? Yes. So since we have got that, I will explain to you what is stack overflow. So if you are getting some exception like stack overflow only you're getting. Okay. Stack overflow exception only you're getting. Okay. See, what is the first site after AI? What is the first site you are getting? Stack Overflow itself, right? The first site that you are getting is Stack Overflow itself, and here you're getting you are that particular like a particular person who has got that error. He has posted some message, and down you have some solutions for it. Some solutions for it what they have given to solve those errors by other developers. So this Stack Overflow is a developers community. Any error, every error, like every year do you get, it will be there in the Stack Overflow. Okay, every compile time error or every exception that you get, it will be there in the Stack Overflow. How it will be there means because before you are coding only, someone has coded that and he got that error. So what he will do basically, this Stack Overflow has all the developers from over all the world, not only India, all over the world. So before only they have got this, before someone has got that error already in the world, many one person has got, one or two persons, they have kept it in the Stack Overflow. They will keep that message in the Stack Overflow and they will ask to the community whether you can solve it. I'm getting this error. Like how you ask to me in the chat box, like that they will ask over the this site. Okay, so that the developer from other corner of the world, okay, like all the developers who are familiar with this error, they will help out to him by sending out the solution, by sending out the description, by changing something. They will do some they will provide some solutions, and you can also contribute to the Stack Overflow. Whatever you know, be an active contributor to the Stack Overflow. That way, that you can keep it in your profile as well. Like I'm an active contributor to the Stack Overflow means the interviewer will understand that you are an active developer. You are an active and a good developer because the developer's work is to not only develop but also debug. Most of the part in any product based company, in any MNC also, if you take, you will develop for like once in a quarter. You will get the development task once in a quarter or once in 2 months, at least once in two sprints you can take it. But maximum of the sprints will be on debugging itself, debugging the code and then extending the code, because the code is will be already written. You will not write the from starting. If you're writing from starting, you are a lucky developer. Means you will learn from starting and you have developed that service, you should be proud of for service specific MNC. But here you will not be most of the time you will not develop from scratch. The code will be already there. You need to just extend it by debugging where I can extend it. You need to check where I should extend the functionality. This is the requirement they will give, and you need to extend that functionality. You need to add more features to that existing functionality. So in that case, debugging plays a major role. Means you need to find out which will break. If you add this functionality, which other old functionality will break, or which it will be affected. What is this? What is that? Everything you need to debug it, and then you need to build it. So that is the way. So basically, while you're debugging many errors, you will get it up. That error, this error, because integration error, something, all everything you will get it up. First, like if you are familiar with Stack Overflow errors, if you have contributed, then you will be familiar with your debugging, right? So debugging as your skill. So make like from now college itself, please try to make a practice of contributing to your Stack Overflow. Okay. So if you can see here, if you can go to the questions section, see all the latest questions will be there here. Okay, newest ones. See, it has been posted around 6 minutes ago. You can take this. You can take this. You can read out. You can read out like what they were facing the issue. Some CSS issue, CSS grid issue. If you're familiar with that issue, then you can go through it. During this time when you are going through this, you will also learn how they are coding. You'll also learn how which practices they are following if you're familiar with this concept. Okay, then if you're able to solve, you can try this in local. You can try this in your local. You can implement this CSS inside your local, and then like if you run it, if you're getting error, or if you have solved after getting error, if you have solved it, then you can immediately mention it in the answer section. If you're posting it in the first position, then you will have much outputs as well. Like in the Reddit, how you will have the upvotes, here also you'll get the upvotes. Okay, like that you can contribute daily to this Stack Overflow as well. This will improve your development skills. Okay, yeah, okay. So Stack Overflow exception, you will get it up when the stack is filled with your recursive calls. Okay, with your method calls. Okay, so at that so like this exception you will get for this code. Then what you need to do if you wanted to stop this, what you can do in recursion, you don't want to go it recursively. What you will do in a loop? What you will do in a loop, in a normal for loop or while loop? What you will be doing? What you will do? Yes. So basically, in a condition, in a loop, you will write a condition, right? Here also in recursive call, you can write a base condition here. To stop this loop, you will be writing a base condition here. Suppose the base condition I'm writing it as if n double equal to 1, just stop that. So for stopping a method call, what you'll be using? You will use a return statement. You will use a return statement. If when double equal to 1, you will be using a return statement. Means return statement in the sense when n double equal to 1, my method call will stop. So means this will not be there, this will not be there. So at only until this point it will be there, right? Until this point it will be there. So loop will be run from 5 to 1. So many times welcome will be printed in this case. How many times welcome will be printed in this case? 5 times welcome will be printed. Okay, so let me code this up. Okay, so I will be calling ABC of 5. Okay, so 5, let me run the loop for static void ABC of int n, and then if n. Okay, I will run the loop directly, ABC of n minus 1. Okay, sys out of welcome. Okay, so if n double equal, like, let me run this now directly. Okay, run as Java application. So what it is telling, it has run to a infinite loop, right? So infinite loop it has went. So to stop this, what I should do, I need to write a base condition, right? I need to write a base condition at the beginning. If n double equal to 1, then return it. If n double equal to 1, then return it. Okay, so run as Java application. So many times it is running, only for 4 times it is running, only for 4 times, because you have started it here at 5th position. Then what will happen, it will come here, it will print welcome, and then ABC of 4. So 5 will be run, 4 will be run, and then it will come inside, and then 3 will be run, and then 2 will be run. Okay, and 2 will be run, and then immediately what will happen now, at first and then 1 it will happen. So now it will come inside, and then it will print, it will go into this condition, it will return, that means return in the sense it will go back to the main, from where it is calling, it will go back to that position. It will return to the before call, basically it will return to the before call. So it will run for 4 times. Okay, it will run for only 4 times it will run. Okay, but if you wanted to run it for 5 times, then what you need to do, you can mention this along the top. Okay, you can mention this along the top. Otherwise you can go with the n greater than 0. Like basically, if n double equal to 0, you can keep it at n double equal to 0. Okay, this will run for 5 times now. 1, 2, 3, 4, 5. Okay, so this is how the recursive calls will happen. Okay, so factorial can be done here. Any changes should I need to do for doing the factorial here? Suppose this ABC, I'm changing to factorial problem. Okay, I'm changing to factorial problem. What I need to do? So factorial in the sense how it will happen. So 5 factorial in the sense 5 into 4 in 5 into 4 into 3 into 2 into 1, right? So 5 in the sense which is nothing but n, right? Then 4, then 3, then 2, then 1. So basically first I'll be making, so first I will pass the 5, and then 5 into, what is this, n minus 1, right? 5 minus 1, right? N minus 1, and then again n minus 1, n minus 1, n minus 1, right? So what I should do here, n into n minus 1. Okay, n into n minus 1, n into n minus 1 I'm writing, and then see what you're getting an error here. Type mismatch cannot convert from void to int. Immediately when I'm writing this, this method call is expecting something, means this one is expecting something. Means you are writing you're not calling the function now. You are writing a integer. You are asking to do something with integer, some operation you are doing. In that case, it should be either in system.out.println, or either it should be somewhere in the operation in the variable or something. But if you're writing like this, immediately it will give an error. Okay, either you should change it to from void to int. You can change it up. Okay, and then you need to return it, because see, return this when you're writing when you're changing this void to int, definitely this will expect a type, right? So for that reason, you need to definitely have a return statement within that method call. So basically, when you're having a return type, definitely you should have your return statement as well. And then what is the base condition here? If n double equal to 1, then what I need to do, I'll be returning that 1, right? So 1 will be returned here. Okay, 1 will be returned here. Okay, so system dot out dot println, system dot out dot println of fact of 5. Okay, let me run now. So it is printing welcome as well, because I have written this on the top. Okay, so what it is printing, it is printing the value. Okay, did you understand, or do you want me to try run this code? Hmm? Okay, so once for all, I will write a stack. So initially what will be called? Fact of 5 will be called, right? Fact of 5 will be called, and then fact of 5 will be called. So it will be coming here, and then it will go inside. Welcome will be printed, and then if down and double equal to not 1, it is not 1. So 1 is not like 5 is not equal to 1. Then it will go here, and 5 into. So what will happen now? 5 into fact of 4. Okay, and then 4 into. So again, it will go to the top. Okay, again it will go to the top. It will start the execution again. Welcome will be printed, and then it is not true. Then it will come here. So what will happen now? 4 into. Okay, 4 into, because n is 4 now. 4 into fact of 3. Fact of 3. Again it will go with the fact of 3. Okay, again the condition is not true. It will go inside, and then what it will print? 3 into fact of 2. 3 into fact of n minus 1, which is nothing but 2. Again it will go here. It will be seeing 2. Okay, again it will come inside. N is double equal to 2. So what will happen? 2 into fact of 1. Okay, 2 into fact of 1. This will be called with 1 now. Okay, now you see 1 is double equal to 1. So what we are doing now, we are returning it. Okay, so currently what is the call that is there? 1 is there, right? Fact of 1 is there. So we are returning this, means it will be moving out from the stack. It will pop out from the stack. Basically return in the sense it will be pop out from the stack. Means it will return to the this one. You are returning some number here. So this will be coming here. This will be coming here in the place of this 1 will be coming. So 2 into 1. Here also you are writing a return statement here. Right? Here also you are writing a return statement. So 2 into 1, which is nothing but 2. This call will also be moving from the pop out from the stack, and it will be moving to the front call. Okay. 3 into 2. 3 into 2. Okay. Here it will be coming 3 into 2. So which is nothing but 6. And then again it will be moving 6 into 4. Okay. 24. Then again 24 into 5. Okay. 24 into 5, which is nothing but 120. 120 will be returned to the fact of 5. Okay. So that will be your answer. Are we good until this point? Okay. Okay. So on this knowledge, let me move back to the kickstart. Let me move back to the kickstart. So basically, these are like simple ones only. So I am taking, you may think like these are like simple ones only, but these are conceptual type. With this problem, I can explain the like your recursion, right? How in the stack trace it will apply. Because to simple ones, if I go and if I explain only, everyone will understand. If I directly jump into some lead code problem and if I do the recursion there and if I explain from there, then whole session you will ask, why are you doing that? Why are you doing that? Right? So for that reason, I'm going conceptually. Okay. Don't feel like I'm taking some beginning level problems or nursery level problems I'm teaching you. Okay. So conceptual level. Okay. I'm taking this problem, I'm making the concept clear, and then I'm moving forward. Okay. So let me move back to the kickshot. Can anyone has idea on this kickshot? How it will work? Give me one moment. I will be back. Yes. So, okay, I got a couple of answers here. Abhisha, Niharika, Mitabi Patan, Anurag, Sunil. Correct. Uh, so basically, in Kickshot and Mergeshot, what I will be doing, I will be recursively, I will be recursively divide the input given. Okay, recursively divide the input given. Okay, divide the input given and then conquer, which is nothing but I will merge them. Okay, then conquer. So basically, so I'll be merging them or sorting them based on that. Based on the order, I'll be sorting them. Okay, in the case of here, kick sort and merge sort. Okay, so let me go with the kick sort first. Let me go with the kick sort first. So let me take 9, 7, 11, 6, 2, 5, 1 and 17. Okay. Mm, So what I'll be doing here, in the case of your kick sort, what I'll be doing here, I will take out the pivot element. Okay, I will take out the pivot element. Pivot element is nothing but some element over your input that is being given. I will take out some element. Okay, some element, and always at that particular position only I will take it up. Okay, if you're taking at any position, you can take it up. You can take it at first also. You can take it at last also. You can take it at middle also. Okay, you can take it at middle also, you can take it at first also, you can take it at last also. But the thing is, once you have stick to the, like once you have taken that particular position in your first iteration, stick to that. Okay, recursively, you stick to that position itself when you are dividing as well. Okay, when you're dividing also, you stick to that particular position itself. Okay, so let me take this as your pivot for now. Okay, pivot as this element. Okay, pivot as this element, and then what I'll be doing, I will take a pointer here. Okay, some start pointer I'll be taking, some end pointer I'll be taking at the end of the array. Okay, at the end of the array, I'll be taking the end pointer. At the start of the array, I'll be taking the start pointer. Okay, so now what I'll be doing, I will be comparing this, like basically, I'm comparing the pivot element, right? I'm comparing the pivot element. Mhm. Okay. So basically what I'll be doing, when the pivot, I will be comparing this pivot element with the next elements. Okay. With the next elements. So basically I will start the loop from start, and this is your end one. Okay, this is your end one, and then I'll be comparing. So what I will do, I will move the start pointer to the right side, I'll move the end pointer to the left side. Okay, but based on the condition, so so basically how I should sort means how the pivot element should be there means, so after the iteration has completed, after that particular iteration has completed, pivot will be at the middle position, pivot will be at the correct position basically. And after this pivot, once your iteration is done, after this pivot, all the elements will be greater than pivot. Okay, greater than the pivot element. Whereas all the elements on the left side will be lesser than the pivot element. Once the iteration is done. Once the iteration is done. Okay, like that, I will move the start pointer also. Start and end pointers also. So basically, what I will do when start is lesser than or equal to pivot. Okay, when start is lesser than or equal to pivot, what I will do, okay, I will move the start pointer. Okay, I will move the start pointer to the right position. To the right position. Okay, to the right. I means I will increment the start pointer basically. I'll move forward. When end pointer, it should come front, right? It should come front. The end pointer should come front. So when end is greater than or equal to pivot, I will decrement the end pointer as well. Okay, basically not greater than or equal to greater than, that's it. Okay, greater than, that's it. Because here we are covering anyways lesser than or equal to. So it will be greater than, that's it. Okay, so basically when the start is less than or equal to pivot, I will increment the start pointer. When the end is greater than pivot, I will decrement the end pointer. Are we clear with the two conditions? Means when we will stop in this case, when we will stop in this case, when we will increment, like this incrementing step will be stopped when start is greater than pivot, basically opposite condition. Then it will stop. Okay, it will stop. It's a stop. Okay, and then when end is lesser than or equal to pivot, then I will put a stop. Okay, otherwise what I will do, otherwise if there is also another condition, if start is lesser than or equal to end only, I should do this process. And start is lesser than or equal to end only. So basically when start is lesser than or equal to end only, then only I should do this process. When start has exceeded the end, when the start pointer has moved forward than the end, then I should stop again. I should stop. Okay, so these are the three conditions I should be doing. These are the three conditions I should be doing. Okay, so now I will take the same input and I will do the I will explain this. So 9, 7. Are you there with me, guys? Yes. 11, 6, 2, 5, 170. I'm taking the pivot as 9 itself. Okay, 9 itself. I'm starting the pointer from here. Okay, I'm ending the pointer from here. Okay, now I will be checking start with pivot element. Okay, 9 is less than or equal to pivot. So basically 9 is less than or equal to 9. Condition is true or false. I should get the response in the chat box. True or false? It is true itself, right? It is true itself. So what I need to do now, I need to move the start pointer here. I need to move the start pointer here. So start pointer will be coming here. Okay. Then again, 7 is compared with pivot. 7 is less than or equal to 9. Condition is true or false? Condition is true. What I need to do, I need to move the start pointer here. Start pointer here. Yeah, we can take any element from array at any position. You can take 11 also, you can take 2 also, you can take 5 also. But the thing is, that position only you should keep it up until the end of your iterations. Okay, for your easy understanding, I was taking the first position itself. You can take any position that you want to mod. Okay, so now so 11 is compared with 9. 11 is compared with 9. So 11 is lesser than or equal to 9 or greater than 9. If the condition is true, it is false. If it is false, 11 is greater than pivot, right? So means the start pointer will be stopped here. Okay, now start will be at here itself. Now we'll go to the end pointer. 17. 17 is lesser than 9 and greater than 9. 17 is greater than 9. So then what I need to do? I need to move this end pointer. 1 is greater than 9 or less than 9? 1 is lesser than 9. It is not greater than. So in that case, what I need to do? I will be stopping the end pointer here and I will be stopping the start pointer here. Okay, now end is already stopped. Start is also stopped. Now what I need to do? I need to swap. Okay, I need to swap your pivot element. Okay, so what I need to do? So basically, I should be swapping, not pivot element. I should be swapping your start and end. Okay, means now what will happen? 1 will be coming here. Okay, 1 will be coming here. 6, 2, 5, and then 11, and then 17. Okay, so end will be here itself, and start will be here itself. Okay, start will be here itself. Again, the pivot will be 9 itself. Okay, again the pivot will be 9 itself. Again the start pointer, again iteration. 7 star, like 1 is compared with 9. 1 is less than 9 or greater than 9. It is lesser than, right? So now what I need to do? I need to move forward. 6 is less than or equal to 9. Yes, again I need to move forward. 2 is less than or equal to 9. Right? Again I will be moving forward. Okay, I'll be moving forward. 5, right? 5 is less than or equal to 9. Again I will be moving forward. 11 is less than or equal to 9. Is it condition is true or false? Condition true or false? Condition is false. Then what I need to do if it is false? I should be stopping here. I should be stopping the start pointer here. Okay, now start is at 11. Okay, then I will be checking with end pointer. 11 is greater than 9 or less than 9? Greater than 9, right? So when it is greater than 9, what I need to do? I need to move this end pointer here. Now if you see, the end pointer has crossed the start, means start has crossed the end. So basically start has went to forward that end. Then in this case, what I need to do? I will stop the iteration. I will stop the total iterations. And then what I will be doing? I will be placing this pivot element. This pivot element, I will be placing, I will be swapping the pivot element with the end pointer. So basically here what will happen? Here 9 you will be getting up and your 11 will be getting. At the end, no, at the end pointer, right? Here you will be getting the 9. At the end pointer, I need to swap. Okay. Mistake. Sorry, I made a mistake. 5 and then 1, right? 5 and then 1. Okay, 5 and then 1. So now what will happen? This 5 will be swapped with 11. Why is it? Okay, it is 11, right? Making a mistake. This eraser. Why eraser is not working? Okay, let me write again. Okay, now 9 is it here only, 7 and 11 is swapped with 1, right? So 1 will be here, 6 will be here, 2 will be here, 5 will be here, 11 will be here, 17 will be here. Okay, now the end is at 1 is also there, right? 11, right? Okay, so 11 will 11 at this 11th position you have the start, and at this pointer you have the end. Okay, you have the end, and then this is your pivot element. So now what will happen, since start has crossed the end, since the start has crossed the end, what will happening, this pivot element will be swapped with the end pointer. Okay, the pivot element will be swapped with the end pointer. So now what will happen, here 9 will come. Okay, here 9 will come, here 5 will come. And if you can observe now, all the elements, if you can see this iteration, all the elements, this is your pivot element, right? All the elements left side twos are lesser than the pivot element. And then all the elements that are right to it are greater than the pivot element. Yes or no? Are you able to see? 5, 7, 1, 6, and 2. These are lesser. And 11 and 17 are greater than the pivot element. Means now the pivot element is at the correct position. Now what you need to do? You need to divide this. The pivot element you should not touch now. You should only worry about these parts. Okay. So now what will happen? Okay, you should only worry about these parts. So means this you need to arrange now. This one you need to arrange, and this one you need to arrange. After arranging, this one you need to arrange, and this one you need to arrange. So what you need to do, you will again take out the pivot element as 5. Take out the pivot element as 5, and what you will do in this will be at the start position, this will be at the end position. Again you should do the same process, means you will run the loop pivot minus 1. So basically you will run the loop from 0 to pivot minus 1, and then pivot plus 1 to n minus 1. Okay, pivot plus 1 to n minus 1. So basically again you will check 5 less than or equal to 5 itself, so you will move the start pointer again. 7 less than or equal to 5. Condition is true or false? Condition is false. So start will be here itself. And then end. 2 less than or equal to 5. 2 less than or equal to 5. 2 greater than 5. The condition is end should be greater than the pivot, right? When end is greater than pivot, then you need to move the end pointer, right? But here you see 2 is lesser than 5. So end will be at here itself. So what you need to do now, you should do a swapping. 7 is moved to 2 and 2 will be coming here. So 5, 2, 1, 6, 7. Okay. Then again the start will be here, end will be here. Okay. The pivot is 5 itself. 5 less than or equal to 2. Condition is true or false? Condition is false. So start will be here itself. And then 7 greater than 5. 7 greater than 5. Condition is true. It will move. 6 greater than 5. Condition is true. It will move. 1 greater than 5. Condition is true. No. So now what will happen? The end will be here. And then again swapping. 5, 1, 2, 6, 7. 5, 1, 2, 6, 7. So here the start will be here. End will be here. Then again I'll be comparing with the pivot. 1 is less than or equal to 5. Condition is true. It will move forward. 2 is less than or equal to 5. Condition is true. It will move forward. 6 is less than or equal to 5. Condition is false. It will be staying here. Okay. And then 2 less than or equal 2 greater than 5. Condition is false. So E will be at here itself. So now what is happening? What has happened? S has crossed E. Now what you need to do then? This pivot element you should be placing at the end position. So now what will happen? this here it will be, here it will be 2, here it will be 1, here it will be 5, and then 6 and 7. Now if you see, now if you see, we are taking red color, right, for pivot. Now you see, before these elements are lesser than pivot, before these elements are greater than pivot. Okay. So again, I will do the divide. Here also divide. Okay. Then here also divide. Like that I will do, and then I will sort the things. For every iteration, the pivot will be at the correct position. And then you should take the pivot here also the first only, here also the first only. Because you should follow the same pattern. Otherwise, you will not get this. You will not get the kick sort. Okay, the same pattern you should be following. You should take the first element itself in everything, in everywhere. Okay. Yeah. So basically, this will be the recursion only. We are following recursion itself. So basically, we are dividing. We are dividing based on the pivot positions, and then we are conquering, recursively conquering each and every partition. Okay. So let me write a solution fast, the algorithm fast, the code fast. Okay. So what you need to do first. Here, for recursively solving, nothing will be there. You need to worry based on partition itself, because recursion anyways, how you will do? From 0 to pivot minus 1, you will do the recursion, and then pivot plus 1 to array of n minus 1, you will do the recursion, right? So that you can directly call those function calls, but the partition is important. So we will do the partition here. So partition will be starting from array. Okay, array, and then start pointer, and then end pointer. Okay, this function. Okay, you need to call this multiple times. This partition function only you should call it multiple times. Okay, then pivot will be at first position, right? The first position you're taking it as pivot, a of s. Okay, and then start, like your start is nothing but okay. Anyways, I've taken okay. Okay, basically here you will be getting you can directly go it from start itself, not okay. Pivot will be a of start, and then I should be writing a conditions, right? So while start is less than end, when start is less than end, you go and iterate. You go and iterate. Okay. While again I should be taking a while loop for your comparing like start. I'm comparing multiple times, right? I'm moving front. So for that reason I require a while loop again. What I need to do, if a of start lesser than or equal to pivot, lesser than or equal to pivot, then what I need to do, I need to move the start pointer, start plus plus. Okay, start plus plus. Then while a of end less greater than pivot, what I need to do, I will minimize the end pointer. We will minimize the end pointer. Okay. Then the last condition, if start is less than end. Okay. So I'm checking, right? If start is less than end. Okay. If end has stopped already and start is also stopped, then what I need to do, if start is less than end, then I need to do a swapping, right? Swapping of your swapping of your start, and swapping of your end as well. Okay, swapping of your end as well. And at the end, I will swap like, I will close out the while loop. Okay, I will come out of the while loop, and then I will be swapping a of start, a of start. I will be swapping a of start, basically a of start with a of end. So basically I will be swapping pivot with end basically. Okay, pivot with end, pivot with end. Okay, I will be swapping pivot with end. Okay, so this will be our solution. Okay, I will be swapping pivot with the end. Okay. So this is your partition logic. Then how should you divide it? How should you divide it? This is your partition logic. You will partition it. So for division, what you need to do, you will be writing, you should call this function. You should call this partition function. So see, when the partition is done, what you will get? You will get the pivot at the correct position. And before this, you need to sort, right? So basically, when the partition is done, what you are doing, you need to again do the sorting from this position, right? This one need to be sorted, this one need to be sorted recursively. Means you need to call this partition function logic recursively, right? So for that reason, the main function again, some main function like quick sort main, quick main, I will write quick main. Okay, so here you will be you will be taking a array. So from main method, you are calling the quick main function. So 0 will be the starting index and ending index will be n minus 1. Okay, n minus 1. Then what you need to do, if if so basically I'll be putting this 0 in one variable, that is lower bound, and then I will be taking end position. The what is the end position, I will take it as n minus 1. Okay, if a lower bound less than upper bound, then what you need to do, what you need to do, you need to find out what is the position of your pivot. What is the position of your pivot? What is that index of that pivot? Okay, what is the in the index of that pivot? So for that reason, what you need to do, you need to call the partition. You need to call the partition lower bound comma upper bound. Okay, lower bound comma upper bound, and then you are calling the. Okay, so I have written wrong actually. So if this is constant, how you will call the kicksort again and again? So I'm taking upper bound here itself. Okay, this is wrong. Sorry. Okay, so what you will do, you will kick main of again kick main. If the partition is done, then you will do the recursively. What you will do, lower bound to pivot minus 1. So basically location minus 1 or index minus 1. Okay, then again you will do the same thing for the next one as well. Kick main of, okay, a of index plus 1. Okay, pivot plus 1. Okay, index, I'm taking it as index itself for your easy. Okay, index minus 1, index plus 1, index plus 1 to upper bound. Okay, index plus 1 to upper bound. I need to do the things. Okay, so this is your kicksort logic. Okay, so I hope you have understood this logic, because this is something like, this is like nothing, it is simple only. I will remove this, why it is coming this. Not able to remove this. Okay, so this logic is simple only. Okay, this logic is simple only. Like, see, whatever I have discussed in algorithm, that only I have written, right? Start less than end, then move the start pointer. When start is less than end, you come inside and execute. And then when start is lesser than or equal to pivot only, you do the start plus plus. When end is greater than pivot only, you do the end minus minus. If start is less than end, what you need to do? The start is less than end, I need to swap it up. I need to swap it up. Okay. So when a start and end are when start and end are stopping, then you need to swap. Otherwise, what you need to do, when start is exceeding the end, what you need to do, you need to swap it up with the pivot element, and you will be returning that pivot location. Okay, you will be returning that pivot location from here. Okay, what you will return basically the pivot location as end position, right? End position, return end. Okay, so this will be coming here. This will be coming to this method call, and then you will kickstart that from index, like basically index plus one to index plus from index like lower bound to index minus one, index plus one to upper bound. You will do the recursive calls. It's 9 o'clock. Okay, so this is how the algorithm will work. Please implement this in the code. Okay, already the code is written. The same code you need to implement it inside your editor. Okay, tomorrow once again I will try run this code within that, and then I will move to the merge sort, and then I will start the linked list as well, linked list implementations as well. Okay, so are we clear until this point? So this will be the assignment for today to implement your kickstart. Okay. Okay. So Kajal, are you referring to assignment answers or assignment questions? Assignment questions. Assignment questions in the notes, you'll be able to find it up already. Like I have shared the assignment questions over there in like problems day 6 as well. Like see, I will open the notes also. Documents, can get that notes. SDP day 6, problem 5, day 5 is right. See, the three problems are given, right? These are only the three problems. Pascal triangle, majority element. Just take a picture of this. Just take the picture of this. Yeah, these were the assignment questions. You should find it on the link lead code. If you're not getting answers, then like where you are stuck, tell me. Tomorrow I will explain this solutions as well. Only three questions. Not today's assignment. It is Sunday's assignment actually. Your Saturday and Sunday's assignment. This is today's assignment is Kickstart. Okay. So please try to complete your assignment. So on that note, I'm winding up here. Thank you so much for joining, and good night.
Yeah, thank you, sir. Thank you so much. Yeah, so thank you, students. We'll wind up for the day. Good night, everyone. Thank you all.